That's a very surprising move.
I thought it was a mistake.
For hundreds of years, people have been playing the board game Go. But the 37th move in the second game between AlphaGo and Lee Sedol changes the game forever. Because AlphaGo is a computer opponent.
I thought it was...
What commentators initially think is an error turns out to be a new milestone in machine intelligence.
Something like this would be a more normal move.
The commentators can't believe their eyes. It's as though someone has clicked the wrong button during an online game.
Okay. Oh, right, that's right, because what you were just saying.
Whole articles and papers will be written about the 37th move. An AI company will even take its name from the 37th move.
But it's like if black continues with this...
And to some extent, the world-class South Korean player Lee Sedol is aware of the implications of the move at the time.
In a second, but Lee has left the room.
He leaves the room for a few
He
minutes.
left the room after that move.
Just to recover from it. It's a very surprising move.
It's a surprising move.
I wasn't expecting that.
No top-ranked player had ever performed a comparable move in the board game with its black and white stones. AlphaGo's artificial intelligence would never have been able to see a move like that itself when it was learning to play Go.
Yeah, that's an exciting move.
The computer had not simply repeated something that had been programmed in. It had applied its knowledge to the game intelligently.
In a strong player's game.
AI and us.
AI and us.
Und wir.
KI und wir.
What artificial intelligence means.
Means for our lives.
Was künstliche Intelligenz
Means for our lives.
Was künstliche Intelligenz für unser Leben bedeutet.
An Alexander von Humboldt Foundation Science
Podcast.
Ein Wissenschaftspodcast
Der Alexander von Humboldt Stiftung.
Episode 3. How do machines learn?
Imagine you wanted to teach an artificial intelligence to recognize photos of dogs and cats.
In the past, we would have to say manually, okay, for a dog, it has to be more round face and the eyes are higher than the mouth. Right now, we gave away this kind of manual control and we say the machine can do that by itself.
All you would have to do is show a modern AI enough photos of dogs and cats. The computer itself works out how to recognize the animals and tell them apart, says Christian Becker-Asano, professor of artificial intelligence at the Hochschule der Medien in Stuttgart.
It's learning what is relevant. It's statistically figuring out by time, okay, this was more relevant than that. For example, the edges in the image were more relevant to distinguish the cat from the dog than the color of the pixels in the picture.
As in this case, programmers feed the AI small programs that can recognize edges or colors, a toolkit of computer code. But the programmers themselves don't have to program how to use the edge or color recognition into the AI to identify dogs and cats or cancers in X-rays, or, by choosing a different toolkit, to find spoken words in voice recordings. Machine learning like this can be used in different contexts, but the principle is always the same, says Milica Gašić, Sofia Kovalevskaya Award winner and professor of machine learning at the University of Düsseldorf.
Machine learning can be summarized with just 3 words, and this is like the 3 most important words in machine learning. And that is data, model, and predictions.
Data is what the system learns from, and you need huge amounts of it. Many hundreds of sample data points are required for AI to learn something.
This data can be labeled. You can listen to the speech and transcribe it, or you can say, user wants this and this, or you can say, well, user was happy here or unhappy here. So all these are labels.
In their simplest form, labels are the desired result. They tell the AI what it is supposed to recognize.
Dog. Dog. Cat.
I'm effectively training my algorithm with lots of pairs of inputs and outputs.
Dog.
Daniel Rückert, Alexander von Humboldt professor at TUM in Munich.
And effectively what I'm going to do is I'm going to basically learn a function which can interpolate between these data points.
Cat. Cat.
And this is how the model is created. Just as we have a vision in our minds of what a dog looks like, the AI model is a network of digital brain cells that are trained to recognize a certain pattern, a dog, a cat, or spoken words. That is a neural network. It has evolved by the AI analyzing more and more sample data. Training data doesn't necessarily have to be labeled. AI can learn all on its own.
The 1978 Atari game, Breakout. At the top of the screen are several rows of bricks. At the bottom edge of the screen, a paddle can be moved to the right and left, which is used to hit a ball ricocheting back and forth between the paddle and the bricks. Each time the ball hits a brick, it disappears and the player gets points. An AI programmed by Google's subsidiary DeepMind learned to play this game. But the game wasn't explained to it. The development team merely told the software that it should achieve a high score in the game. The artificial intelligence didn't just learn to hit the ball. After a few hundred rounds, it discovered that the easiest way was to use the ball to dig a tunnel through the rows of bricks. When the ball then shoots through the tunnel over the rows of bricks, it takes a load of bricks with it, and the score soars.
The system thus learns that desired behavior is rewarded.
And that's very central to the AI algorithms that we have today, that the systems can get a reward or punishment when they produce an output.
Reinforcement learning is the name given to this method. AlphaGo, the AI that surprised the Go community with its unusual but effective moves, learned in a similar way. It played countless rounds against itself and thus got better and better. A later version of AlphaGo learned the game without having to be trained using recordings of games played by humans. Experts refer to this as unsupervised learning.
When we go to the point of doing unsupervised machine learning, things become much more challenging because we don't really know what is the right output for a given input. So we have to infer that from the data, and there are many more different interpretations of the same input data which I can make, and that becomes very, very challenging and very difficult to deal with.
That's why AI systems still often learn by example, based on data from the past. They recognize patterns in the data, and then they try to find these patterns in the new data they are given.
KI ist viel stärker datengetriebene Technik, als das andere Formen der Informatik sind.
AI is a much more data-driven technology than other forms of computer science, and that is precisely why AI is very susceptible to existing disparities in the data that are used to build artificial intelligence. After all, this input is not neutral.
Dieser Input ist ja nicht neutral.
So AI evolves in a society in a highly structured social, linguistic, economic, and cultural context, if you like. And of course, these preconditions also influence the AI.
Und diese Vorbedingungen beeinflussen natürlich auch die KI.
Tobias Matzner, professor of Media, Algorithms and Society in Paderborn, says artificial intelligence more or less learns how our society ticks in passing. So it also learns hierarchies, evaluations, worldviews. Data is not neutral. It always reveals a pattern.
Das ist ja die Aufgabe der KI, diese Muster zu finden und ernst zu nehmen.
It's AI's job to find these patterns and take them seriously. And that's why it often reacts very sensitively to them.
Und genau deswegen reagiert sie dann oft auch tatsächlich sehr sensibel darauf.
Time and again, we realize that artificial intelligence adopts the discriminatory behavior in our training data. This also happens in medicine, where, for example, Black patients are treated differently from white patients. Even though criteria like this is not explicitly included in patient data, the medical histories of people from different social or ethnic groups differ. But AI doesn't know that we want to overcome this inequality. It replicates it. Despite these unacceptable weaknesses, artificial intelligence has advantages that should not be ignored, even when it only replicates human knowledge.
One of the big advantages, for example, in medicine, what we can do is we can, for example, pool data from different experts. So I think you will probably also have come across the scenario where you go to a doctor, the doctor does a diagnosis, and perhaps if you then go next day to another doctor, there might be some differences between these different diagnoses by the different doctors. And what we can do is we can then, for example, pool these different expert opinions, and a very well-known assumption in machine learning and also investigated and supported theory in machine learning is that we pool data from different experts. On average, you get a better answer than if you ask just one expert.
An AI can consolidate the knowledge of many human brains. It can learn from far more examples than a single human ever could.
We can train these machine learning algorithms with data from millions of examples and millions of humans. And quite often, your average doctor, which you might visit on a Thursday afternoon, and you have a very rare condition, has perhaps only seen that rare condition in 2 or 3 cases in their life.
But there is a hitch. An AI doctor can't necessarily explain how it has reached a certain diagnosis. Many AIs are unfathomable, a black box.
Many researchers in the biomedical field would, for example, say that a black box AI algorithm is not very useful because they also want to understand the mechanisms behind certain processes.
In the next episode, do we know what AI is doing?
This was episode 3 of AI and Us, a science podcast by the Alexander von Humboldt Foundation. The Humboldt experts in this episode were Christian Becker-Asano, Professor for Artificial Intelligence at the Hochschule der Medien in Stuttgart. Milica Gašić, Sofia Kowalewskaja Award winner and Professor of Dialogue Systems and Machine Learning at University Düsseldorf. Tobias Matzner, Professor in the Department of Media, Algorithms and Society at Paderborn University. And Daniel Rückert, Alexander von Humboldt Professor for Artificial Intelligence in Healthcare and Medicine at TUM Munich.
The surprising 37th move in the second game between AlphaGo and Lee Sedol was decisive and assured the AI victory. The final score at the end of 5 games was Machine 4, Human 1. At the subsequent press conference, Sedol said,
I kind of felt powerless.
결과론적으로 따지면 사실 1국은